students, in this video I'm going to work the problems for lesson 5B from Unit 3. If you're watching this video on YouTube, you will find a link for a Google shared document, which is the link to the handout that my students are working with in this video. So there are 10 problems on this assignment, and the first 4 do not have complex or irrational roots, but numbers 5 through 10 have complex or irrational roots. So the first 4 will be a review of our lesson on just doing the problems with without the irrational and complex roots. And the original instructions say write the polynomial in standard form. I'm going to take these as standard form, but typically I would accept intercept form. I would accept if you just left it in intercept form. So problem number 1 asks us to write a cubic polynomial. So we know that the total degree is going to be 3. It only gives us one root, so that's going to be our one factor with an exponent of 3. But it also gives us a point that it goes through. So we want to pay attention to that, because if you see goes through the point and then it gives you an ordered pair, you know that you need to find that a value. The a value is not going to be 1 on this one. So let's start out by writing y equals a times, and then our one root is at 6, so that means it's going to be x minus 6 in parentheses. It's cubic, so that's going to be a 3 exponent. Now we need to find what a is, which remember we use our ordered pair that we're given, and we plug in the x and the y into our original equation. So I'm going to plug in a 16 for y. Keep my a the same, keep my a as the unknown, but we can only have this one unknown to solve for it. And then plug in a 4 for x. And then when we only have one variable that's unknown, we can solve for that variable. So we're going to do this math here. 4 minus 6, negative 2. Negative 2 squared is negative 8. So 16 equals a times negative 8, so we're going to divide both sides by negative 8. And we find out that a equals negative 2. So then we just go back up and plug in the negative 2 for a. So I would accept this, but I'm going to go ahead and take this and multiply it and get standard form. This is intercept form, if you remember. And this would be acceptable for me. But our directions tell us to do standard form. So we're going to go ahead and multiply this out, which means we have to write the x minus 6 3 times. So I'm going to go ahead and multiply the negative 2 into this one. Put that in parentheses, and then I'm going to multiply these two binomials and put those in a separate set of parentheses. So that's x squared minus 12x plus 36. Then I'm going to need to multiply this binomial times this trinomial. I'm going to pause my video and go ahead and do that, and then I'll give you the answer in standard form. Okay, so here's your answer in standard form. That's supposed to be a 6 right there. So standard form looks like this, but again, I would accept intercept form. I just multiplied everything out to get standard form. Okay, so number 2 also asks for a cubic polynomial. So we know again that our total degree, when we add them up, is when we add up the exponents on the factors, is going to be a 3 again. It gives us 2 x-intercepts this time. Remember, x-intercepts, roots, zeros all mean the same thing. So you might have problems that say x-intercepts. You might have another one that says zeros. It's all the same thing. So our x-intercepts are at 2 and 4. So I already know I'm going to have one factor that's x minus 2, and another one that's x minus 4. It says it bounces at 4, so I know that's going to be my 2 exponent. So 2 plus 1 is 3, so those are my 2 factors, and goes through the point 6, 8. So I know I'm going to have an a here, and I'm going to need to figure out what that is. So there's my original equation, and I need to fill in an 8 for the y and a 6 for the x's. Now let's solve for a. 6 minus 2 is 4, and then 6 minus 4 is 2. 2 squared is 4. So 8 equals 16 times a. Now this one's different than last time. We're dividing by 16 this time, so we're going to get a fraction. So a equals 1/2. I'm not going to go ahead and multiply this one out to standard form. Let's just write our factored form, our intercept form, and we'll leave it at that. So a 1/2 goes right here where a is. So my answer looks like this. And if you wanted to, you could go ahead and multiply all that out. I can tell you what the answer would be if you did do standard form. There we go. There's standard form. Number 3, once again, we're asked to write a cubic polynomial. We are given, oh, this is interesting. It says it passes through the x-axis at -2 and 1 and 4. And so what that means is these are the x-intercepts or the zeros. So I'm going to have a factor of x plus 2, x minus 1, and x minus 4. And that makes it a cubic polynomial. Let's go ahead and put our a here. Okay, and then we're going to plug in the 3 and the -30 and solve for a. Sorry about that, I had to rewrite this. Okay, so 3 plus 2 is 5, 3 minus 1 is 2, so that's 10. 3 minus 4 is -1, so 10 times -1 is -10. That means -30 equals -10a. Divide by -10, a equals 3. So again, we're going to write this in intercept form and leave it that way. I will give you the answer in standard form though. So let's see, we have y equals 3 times x plus 2, x minus 1, x minus 4. Standard form. Three x cubed minus 9x squared minus 18x plus 24. Either one of these is acceptable. This is intercept form, this is standard form. One thing I wanted to remind you about is that when you're looking at intercept form and you want to know what degree the polynomial is, you add up the exponents. So you've got a 1 there, 1 there, 1 there. So you add them up. But when you're looking at standard form, you don't add up the exponents, you just look at the highest degree. So that's where, you know, cubic comes from, the highest degree in standard form, and it comes from adding the exponents in intercept form. So here we're asked for another cubic polynomial, has zeros at -3 and 6, passes through the points -6, 0, and 336. So this right here is the point that we're going to use to find a. The fact that it says it passes through -6, 0, that tells me it passes here, so it has to bounce at the -3. So let's write it that way. We're going to write y equals a. We're going to find a in a minute. X, let's do x plus 3 first. And x plus 6. Now, again, it says it passes through the point -6. So that means this is going to have an exponent of 1, which, since it's cubic, that would mean that the x plus 3 would have to have an exponent of 2. So I'm done with this point because that's what that is right there. So now I need to use this 336 to find a. Sorry, I wrote a 6 there. I should have written a 3. Let's change this to a 3. 3 plus 3, 3 plus 6. Okay, so I've got, let's see, 3 plus 3, 6. 6 squared is 36 times 9. Oh, let's do this. 36 equals, okay, so I'm just going to put 36 here. And I'm going to put 9 here. So that I don't have to multiply the 36 times the 9, I can divide both sides by 36 right here. Cancel that. And then I get 1 equals 9a. So now I divide by 9 on both sides, and I get a equals 1/9. Okay, so that's a. Go back over here and rewrite that. Okay, that's intercept form. Let me give you standard form. Okay, so again, leading the leading term degree is 3. That's cubic. And over here, 2 plus 1 is 3, so this is cubic. So this intercept form, standard form. Okay, so for the rest of these problems, we do have irrational or complex imaginary roots. And so we are going to be multiplying these out to standard form. Mainly because if you have an imaginary root, you can't put that in your graphing calculator and graph it. You also can't put it in Desmos and graph it. So we want to get rid of those imaginary roots. And by using the complex conjugates, which we know we're going to be using, it gets rid of the imaginary and irrational roots. Okay, so write a quadratic polynomial, number 5, with roots at square root of 11 and a leading coefficient of -4. So it tells us what the leading coefficient is. That's the a value. And it says it's quadratic. Do not get this confused with quartic. Quadratic means it needs to have a degree of 2. We know that if we have an irrational root, such as square root of 11, we're going to have a pair that goes with it. So there's going to be a root at root 11, and there's also going to be one at negative root 11. So we know that our factors are going to look like this. So we have to have those pairs that go together. If you remember from our previous lesson, we also have a -4 right here. That's our a value, and then our y is here. We are going to go ahead and multiply these out. I'm not going to multiply the -4 in until I have multiplied these two. If you notice, this is the same two terms, and there's a plus and a minus. That means that is a difference of 2 squares. And so I can really ignore that middle term, but I'm going to go ahead and multiply them out this time and show you what I'm talking about when I say middle term. So I'm going to multiply these two binomials together. That's going to be x squared, and we'll put it in parentheses because I might end up multiplying that -4 in. That's x times x. X times negative root 11 is negative x root 11. And then root 11 times x is positive x root 11. And then root 11 times negative root 11 is going to be negative 11, because a square root, or a root times itself is going to be just whatever's under that radical. Okay, and so when we square something that's under a radical, you know, we just take it out from under the radical, and it's a positive times a negative. Okay, let's put our parentheses there. Now, here's my two terms that cancel out. This one, negative x root 11, and positive x root 11. So I don't really have to do that every time I do every time I do a problem like this, because I know that the middle two terms are going to end up canceling out. So now I'm left with x squared minus 11. I'm just going to rewrite that. I have to multiply that -4 in. And when I do that, just use distributive property. That's negative 4x squared plus 44. So that is our answer there. And you notice it still has that leading coefficient of -4. It is a quadratic. It is because it has an exponent of 2. Okay, the first thing I want to look at on number 6 is the fact that it says there's a 0 at I. If there's a 0 at I, then there is also a 0 at -I. So I just want to make a note of that. It says it's cubic. So with 1, 2, 3 zeros, I know that each of those factors is going to have an exponent of 1. So I'm going to have an x minus 2, an x minus I, and an x minus -I, which is x plus I. It gives me the a value. The a value is 1/4, so I can put that there. And there's my equation. I just need to multiply everything out. I'm going to multiply these two first because these are the ones with the imaginary root. And you see these are complex conjugates. X minus I and x plus I are complex conjugates. That's the pair that we have to have for a problem like this. Okay, I had to switch this because I was going to multiply the 1/4 in right here, but I think it's actually going to be better to wait till the end to multiply in the 1/4. That way I'm not dealing with a fraction until the very end. So let's multiply x minus I times x plus I. All right, x times x is x squared. Then I'm going to have those middle two terms that are going to cancel out because this is a difference of two squares. And then I'm going to have minus I squared. Minus I squared. I'm going to write that over here. I squared is -1. So minus -1 is plus 1. So this is x squared plus 1. Now I'm going to multiply these two binomials. And at the end, I'm going to multiply in that 1/4. So I'm still going to keep the 1/4 there. X times x squared. Let's see. X times 1, -2x squared, and minus 2. It's a little bit out of order, but we can change it in a minute. Okay, now I'm going to multiply in my 1/4. And when I multiply 1/4 times x cubed, I'm just going to write x cubed over 4. You can write 1/4 x cubed. That's fine. 1/4 times 1x is x over 4. And then times -2x squared, I'm going to go ahead and simplify that. -2/4 is -1/2. And then that's going to be -1/2. Now, I want to write it in standard form. This is not in standard form because I have these two are out of order. So I'm going to write it over here. I just need to switch these two so that they're in descending order. Y equals x cubed over 4. Again, you could write 1/4 x cubed, same thing. Minus x cubed over 2 plus x over 4 minus 1/2. So this is standard form with your exponents in descending order. I wanted to show you that there are several ways this could be written. This was the way that I chose to write it. You could also have written it with the fractions and then the variables beside those, and then you could have written it with decimals. This would not be incorrect either. It's just that when you're looking at an EOC or final exam and it's multiple choice, you need to understand that all three of these things are the same. They're the same. They are equivalent equations, and so just wanted to show you that there are several possibilities for writing the answer in standard form, and none of these would be wrong. You just need to be able to recognize it on your EOC. Number 7, we have a quadratic polynomial. Remember, that's an exponent of 2. Passes the x-axis at -7i. So if it has a root at -7i, it also has to have one at +7i. A value of 6. So we could go ahead and write this with the 6 here. It's going to be x minus 7i and x plus 7i. Okay, so then this is a difference of two squares. We're just going to multiply this out and write it in standard form. I'm going to wait till last to multiply the 6 in. This is going to be x squared. Now, I want you to think about this. -7i times +7i. That's going to be -49i squared. So that would be -49 times -1, so plus 49. X squared plus 49. And then we just need to multiply the 6 in. Use distributive property. Plus, what was this one? 294. Okay. And for this one, that's pretty much the only way to write that one. 3 more to go. Number 8 says write a cubic polynomial with roots at 6 and root 2 and leading coefficient of -3. I would encourage you at this point to pause the video and see if you can set this up, thinking about the fact that there is an irrational root here and it needs a conjugate. So pause your video and see if you can set it up and then come back and see if you got it right. Okay, hopefully your problem looks like this. You have your leading coefficient -3 here. You have a root at 6, so that's x minus 6. You have an x plus root 2 and an x minus root 2, and it is a cubic polynomial, 1, 2, 3. Okay, so let's go from here. Again, I would encourage you to pause your video and see if you can go ahead and multiply everything out and see what you get. So I'm going to go ahead and restart it at this point because I did multiply my x plus root 2 and my x minus root 2 and got x squared minus 2. And so now I'm going to multiply these two binomials together and then multiply the -3 in last. So my next line looks like this. I multiplied these two binomials together, and I went ahead and put them in standard form. This is not how I would have normally had them in, I wouldn't have had them in this order, but I went ahead and put them in standard form. So now I'm just going to multiply my negative 3 in. This is going to be plus 18x squared, and then plus 6x minus 36. Okay, so their standard form is still cubic. Leading term has a exponent of 3, and also the leading coefficient is still negative 3. Number 9 asks us to write a cubic polynomial with x-intercepts at 3 and at negative root 5, so we know there's also going to be one at positive root 5. It doesn't give us an a value, and it also doesn't give us a point that it goes through, so we're going to assume that the a value is 1 here. So our equation is going to look like this. We have x minus 3, we have x minus root 5, and x plus root 5. So I'm going to multiply these two first because that will get rid of that radical. So I'm going to rewrite the x minus 3. And then over here I'm going to have x squared minus 5. And then I can multiply these two binomials. Let's see, that's x cubed, and then x times negative 5, negative 5x minus 3x squared plus 15. So the only thing I need to do now is rearrange this so it's in standard form because my exponents need to be in descending order. Let me check my key and make sure I got it right. I think I did something wrong. Let's see. Oh, I just copied this part wrong. That should be a minus right there. Let me fix that. It should be minus 3x squared. So our last problem asks us to write a quartic polynomial. That means it needs to have a total degree of 4. Our zeros are negative 5, 1, and 4i, which means we also have a factor at negative 4i. Or a root at negative 4i, excuse me. So our factors, and we don't have, it doesn't say anything about a leading coefficient, so our leading coefficient is 1. So our factors are going to be x plus 5, x minus 1, x plus 4i, and its complex conjugate, x minus 4i. Okay, so what I'm going to do is I'm going to group these binomials together. So I'm going to multiply these two binomials and then these two and go from there. Now, when I multiply these two, I get x squared. Now, this is going to be positive 5x and negative 1x. I'm going to go ahead and combine those now to positive 4x, and then 5 times negative 1, negative 5. All right. Yep, okay. These two binomials, x squared, my middle terms cancel, and then positive 4 times negative 4 is negative 16. But negative 16i squared is positive 16. So this is going to be x squared plus 16. I'm going to rewrite this, and I'm going to switch this one to the beginning. Let me just double check. Okay, I'm right so far. Now, the reason I like to do this is because I've got a binomial and a trinomial, and if I'm going to multiply those two together, I like to distribute 2 terms in instead of 3. It's just, to me, it's easier. Okay, so let's do that. X squared times x squared, x to the 4th. X squared times 4x, x squared times negative 5. Okay, so I'm done with this one. Let's distribute the 16. That's going to be plus 16x squared. This is going to be plus 64x. And 16 times 5, negative 5, excuse me, is minus 80. Now let's see if we have any terms we can combine. And we'll finish this out. This is x to the 4th. I have only one x to the 3rd term. I have a -5 and a +16. So that's plus 11x squared. And then the rest of it is going to bring down plus 64x minus 80. All right, and that will do it for this assignment. Let me know if you have any questions.